Hey everyone, welcome back to the channel. I'm Shashank S, a student of SPCE. In this video, we'll be learning about fundamentals of logic, which comes under mathematics. So first, we'll be going through the introduction part in this video. Then we'll be knowing what are prepositions and truth table. Then we'll be going through the logical connection and logical equivalence, tautology and contradiction. And at the end of the video, we'll be learning about quantifiers and some rules of inference. So, moving into the very introduction part of logic, logic is a fundamental part of mathematics and computer science. It plays a very crucial role in understanding and analyzing the relationships between ideas and reasoning. So, by studying logic, one can develop a systematic approach to thinking and problem solving. Okay, so what are prepositions and truth values? Prepositions, they are declarative sentences that can be assigned a truth value, either true or false. And when it comes to truth values, they represent the truth or falsity of propositions, and they are typically denoted by T for true and F for false. Examples. Some examples of prepositions include the sky is blue. So here the sentence is true and it is denoted by T. And in terms of numeric, 2 plus 2 is equals to 5. So this statement is false and it is denoted with the letter F. When it comes to non-preposition, non-prepositions such as questions, commands, or exclamations do not have truth values. Logical connectivities, conjunction, that is and, which is used for multiplying. The conjunction of two propositions is true if and only if both propositions are true. Disjunction, or the disjunction of two propositions is true if at least one of the proposition is true. Negation, that is not good. The negation of a proposition is true if and only if the preposition is false. And when it comes to conditional, that is if then, a conditional statement is true unless the antecedent is true and the consequent is false. Biconditional, if and only if. A biconditional statement is true if and only if both prepositions have the same truth value. So what are truth tables? They are a visual tool used to represent the truth values of logical propositions. They show the truth value of a compound proposition for each possible combination of truth values for its constituent propositions. Each row in a truth table represents a different combination of truth values for the prepositions involved. Logical equivalence. So, logical equivalence is a fundamental concept in logic that establishes when two logical expressions have the same truth value under all possible truth value assignments for their variables. This means that the expressions here are interchangeable in any logical context as they always produce the same outcome. Truth table. The most straightforward way to demonstrate a logical equivalence is through truth table. So replacing one equivalent expression with another is called as substitution, and pre-established equivalence for common patterns comes under logical laws. There are different methods to determine logical equivalence. Truth tables provide a systematic way to compare the truth values of expression. Alternatively, one can rely on substitution, replacing one expression with another known to be equivalent. And finally, there are established logical laws such as De Morgan's laws that directly indicate certain equivalences. Conditions of tautologies and contradictions. When a statement is always true, then it comes under tautology. And contradiction refers to a statement when it is always being false. But tautology is a proposition that is always true, regardless of the truth values of its components. A contradiction is a proposition that is always false. A contingency is a proposition that can be either true or false depending on the truth values of its components. And identifying tautologies and contradictions is a very important thing in logic because it allows us to determine the validity of arguments and the consistency of theories. It also helps us to understand the relationship between different propositions. Arguments and validity. An argument is a set of statements called premises which intend to support a conclusion. The validity of an argument is determined by the logical connection between its premises and the conclusion. A valid argument is one where the truth of the premises guarantees the truth of the conclusion. So this does not necessarily mean that the premises are there, but rather that the argument structure is logically sound. Premise: statements which supports the conclusion, and conclusion means the statement which is being supported. Validity: the logical connection between premises and conclusion is known as validity. Soundness: a valid argument with true premises. If one argument is not valued, then it is possible for the premises to be true while the conclusion is false. Such arguments are called invalid. A sound argument is a valid argument with true premises. Sound arguments are the most convincing type of argument as they provide both logical support and factual accuracy. Inference rules. Modus ponens. If P implies Q and Q is true, then it states that even the Q must also be true. So this is a fundamental rule of logic which allows us to draw some conclusions from conditional statements. Modus tollens. If P implies Q and Q is false, then P must also be false. So this rule helps one disprove hypotheses by showing that their consequences are not true. Hypothetical syllogism. If P implies Q and Q implies R, then P implies R. This rule allows us to chain together conditional statements to draw more complex inferences. So moving into the last topic of the video, quantifiers. So universal quantifiers. The universal quantifiers means for all or for every. It is used to express a statement that is true for every element in a given set. Existential quantifiers. The existential quantifiers means there exists or there is at least one, which is used to express a statement that is true for at least one element in a given set. Combining quantifiers. Quantifiers can be combined to express more complex statements. For example, there exists a number that is greater than all other numbers which uses both quantifiers. So, what are the applications of logic? Logic finds practical applications in various fields, influencing how we think and solve problems. Computer science. Logic is fundamental to computer programming and artificial intelligence. Mathematics. Logical reasoning is essential in proving mathematical theorems. Philosophy. Logic helps analyze arguments and evaluate truth claims. Everyday life. Logic assists us in making decisions and understanding arguments. Yeah, so that's all in this video. If you guys found this video helpful, please do like and share it, and do subscribe to my channel. Thank you.